It is great to follow the success of our corporate members. You have seen in previous editions of OFC that we always look at a company coming all the way from Canada that could do crazy things with 3 micrometer femtosecond lasers. The company is called Femtum, and I'm here with Louis-Raf, the CEO of Femtum. You have done crazy things on the last years, and now you are ready here with a full working equipment that does the magic. Can you tell us what's in front of us?
Thank you, Jose. It's super exciting days. This machine is the world's first photonic wafer laser trimming in the world. Actually, one of the biggest problems in photonics is that the cost is still very high, and it's because the yield is very low. And what we're doing here, it's basically changing the phase by modifying locally the refractive index with ultra-fast pulses, and we do this at wafer scale.
So laser trimming, you are actually fixing broken chips.
We are indeed fixing broken chips.
On the wafer.
On the wafer, and it's live right now.
At the same time, it gets tested.
You have to do the first test, and then when you know exactly the real response of the optical circuit, then you fix it with the laser. So it's a bit like the LASIK for the eye, but for the waveguides.
The whole event today had a really strong push for wafer-level testing. You're doing wafer-level testing and trimming.
Exactly, and it's a partnership with ficonTEC. So we're adding on optionality, and this can bring a lot of value to the customers.
So this is already a product. People can actually already put this in the manufacturing facilities.
It's a product. It's a rack mount fiber laser. Everything has been designed inside with the optical head. It's mass manufacturable.
Okay, show us the magic.
Yeah. So over here, what you're looking at is the wafer map of the process variations. And here, what we are measuring is the first initial response of a Mach Zehnder. It's an unbalanced Mach Zehnder, which are used everywhere in the switches. They are used for filters. They are used for modulators. And what you will see here in a few seconds, if you're lucky, we'll see that the phase shift of unbalanced Mach Zehnder is not spot on. What we have done here is predict the process parameters and correct the phase response, and we can target and locate directly at 1310, which is a datacom wavelength. We do this all in an ultra-fast fashion. It's quick, it's permanent, it's long-lasting. We have done a very nice reliability test, and it's embedded now in the ficonTEC system. I'll try just to open the door and stop the machine so you'll be able to see the full thing. We'll have to wait a second. It needs to finish one job. And now it's okay. So what you're seeing here, it's a real wafer from a customer. It's a 6-inch wafer. You have a 2-axis east-west optical probing, and you see the Femtum head inside. It has collinear optics. We are focusing the beam right onto the waveguides, and we're changing locally the refractive index. You have the vision, you have the illumination, you have the galvo scanner, fiber beam delivery. Everything is connected and ready to go. So that's the beauty of the new photonic wafer laser trimming solution.
So this is available today, and that was the result of many years of hard work. What do we look for in OFC 2026?
So OFC 2026, actually, it will be a lot of first deployment with the customers. This project will come to circuit level, so we're going to trim a lot of circuits, so a lot more data.
A lot of companies today, they have been showing pluggable transceivers, they have been showing CPO. The biggest question that we have at the Executive Forum is, of course, reliability. We need to show to the customers that chips, once they leave the fab, they are fully tested and now they are fully repaired. Does this make you excited?
Yeah, exactly.
You are working with some of the key manufacturing centers globally. What do they need to know from you? What is the key message that they can use to incorporate this to the fabs?
So one of the critical thing is that today designs of PICs are very hard to manufacture and the yield are low. And there's a lot of impossible designs. And with laser trimming, with the post-fabrication reworking solution, then you can extend the tolerances of the PIC design and actually deliver new design which were impossible before. So the designers need to understand that now it's possible to rework their photonic waveguides and basically make their yields higher.
Femtum, originally at least, you were a laser manufacturer, and were you using 3 micrometer lasers? What is the magic of that particular wavelength?
So 3 micron is key because you can be super selective to the right layer stack. And you know, semiconductors, we can use now multi-photon absorption process, and 3 micron enables that. So the laser source is really an enabler for the cleaning and the trimming.
What we are seeing is that the manufacturing of silicon photonics today is starting to be led by the big semiconductor fabs, which operate with very large wafers. Can you tell us a bit about the operational time? How long does it take to trim a wafer?
The trimming is actually very fast, and it's at that speed. So it's less than half second per structure, per circuit. It's super fast. So we're shining with Galvo scanner. Actually, what takes time is testing and motioning, and people are pushing really hard with our partners to reduce that time.
So let's play the crystal ball game. This is my favorite question. It is OFC 2030. CPOs are everywhere. We have replaced copper with photonics, and now how does Femtum look like?
So 2023 will be a crystal year for us because not only trimming will be everywhere, but cleaning as well.
Cleaning?
Cleaning. So a lot of advanced packaging right now requires a lot of clean surfaces, and a lot of the cleaning are done manually. So what we do at Femtum, we have developed an automated way to do the laser cleaning of photonic chips, of CPO packages, of fibers, of the V-groove, and we make all those surfaces super clean so you can hit the yield that you want at scale.
Tell us more about this. Why chips need to be cleaned?
So if you can imagine, all those surfaces, when you do the assembly, the bonding needs to be 100% clean, because one particle will just do a misalignment and you will get optical losses. Or it will be exactly at the coupling region, and that coupling region needs to be 100% clean. Otherwise, the laser at 1550 or at 1310 will be hitting the particle and will burn. So it will be reliability issues. So actually, there's a huge specs on getting everything clean and done quickly at the OSAT, at the backend foundry line.
And cleaning at the wet bench of the fab is not enough.
So people right now, everywhere, are wiping off with Q-tips, and it's done manually. It's not automated, and it's known in the industry. All the OSATs are doing this like this right now.
How do you do it with a 3 micrometer laser?
We shine pulses on the particle that are contaminated in the residue. And since we have 3 micron laser technology, it's selective, and we can ablate the particle in the residue without affecting the substrates, which are glass or silicon.
Has this already been deployed?
So right now we are in very advanced process with key customers. I cannot say more about that, but we are at this stage where cleaning is also another big step forward for Femtum.
So in short, if you want to do wafer level cleaning, wafer level trimming at the same time as you're doing wafer level testing, the place to go is Femtum.
Exactly.
Congratulations on everything you're achieving.
Thank you, Azay.